Welcome. In this video tutorial we will use WebLink to create a simple slideshow style experiment in which participants view a series of images and videos for fixed durations. The tutorial covers use of participant and user variables as well as use of WebLink's image and video components. It also demonstrates the use of repetition sequences. At the end of the tutorial we will take a quick look at the gaze recordings in Data Viewer. The experiment that we will implement is very basic. Participants will view 4 static images of faces and 4 videos of faces. Half of the faces will portray on neutral expression and half will be happy. The trials will alternate between images and videos. The basic idea is to see if there are any differences in how people view static versus dynamic faces and whether there is any interaction with emotion. Obviously a proper experiment would use more than 8 stimuli, but I'm keeping it simple for the purposes of this tutorial. As ever, we start in WebLink by making a new project and saving it. We'll leave the experiment configuration settings at their default values for now. Next, we'll add some image and video stimuli to the project library. The library manager has tabs for images, audio files, interest area sets, videos and PDFs. I'll start by adding some images. These include the static face stimuli as well as a basic instruction screen that I made in PowerPoint. Clicking on the imported images gives a preview and shows some basic file parameters such as the pixel dimension. WebLink can deal with a wide range of image and video formats, but can be a bit fussy about file names, so make sure to avoid spaces and special characters. Next, I'll add the video stimuli. Again, clicking on the imported videos allows you to preview the video and see some basic file information such as the size and duration. In the experiment configuration settings, I'm going to define some user variables. These will come in useful when we analyse the data in Data Viewer. The stimuli differ on 3 dimensions: images versus videos, neutral versus happy faces, and male versus female faces. I'm going to add each of these variables as an option type, separating the 2 options with the slash symbol. Now we can begin to add components to the timeline. At the start of the experiment I would like to show an instruction screen, so I'll drag an image component to the timeline. I'll change its label. WebLink automatically selects the first image in the library, but we can change that in the settings and choose the appropriate file. My image is a bit small, but WebLink allows images to be resized and repositioned. I'll make it a bit bigger, but keep it central. We're not interested in recording eye movements at this point in the task. We haven't even calibrated the eye tracker yet, so I'll set the record eye movement data property to no. I'd like the screen to stay visible until the participant presses the spacebar, so I'll change the keyboard response property. I'll uncheck the mouse response property too. Next, we can drag down a camera setup component to the timeline. Again, the default settings are fine for this project. Now we can add the image and video components that will present the trial stimuli. In order to make sure that everyone is looking in the same place when the stimuli appear, I'd like to show a central fixation cross first. I don't currently have a fixation cross image in the project library, but I can just create a suitable image in software such as PowerPoint, for example, and then add it via the library manager. Now I can add another image component to the timeline, change its label to something sensible, and change the source file property to the fixation cross image. I'd like the image to span the full screen, so I'll adjust the size properties. The fixation cross should stay on the screen for 500 milliseconds, so I'll set the max duration property to 500 and uncheck the keyboard and mouse response entries. Next, I'll add another image component to the timeline to show the first face image. Again, I'll change the label and adjust the image's size. I can also change the background color to white. This time I'll set the max duration property to 6000 milliseconds. Again, we don't want the image to end on a key press or mouse click, so I'll unselect these properties. Notice that the user variables we defined earlier are listed in the Properties panel. I'll go ahead and select the appropriate values for this image. Now we need to show another fixation cross. Rather than drag down another image component, we can just copy the first one, select the next component, right-click and select Paste After. We can change the label too if we want. Next, we drag a video component to the timeline. This is much like the image component, so I'll change the label and select the first video file. One really neat feature of WebLink is that it can resize videos as well as images, so I'll change the size to match the image, adjust the background color, and also set the max duration property to 6000 as before. Finally, I'll adjust the user variables. Now at this point I could copy and then paste these four components in the timeline, changing the source file properties and user variables, and repeat that process until I have a long line of components and all of the image and video stimuli are presented in turn. That might be fine for a relatively short project such as this one, but could become cumbersome for projects with lots of stimuli. Instead, we'll use another really neat WebLink feature, which is to create a repetition sequence. The task design is that faces and videos alternate, so I can just select these four components, right-click and select Create Repetition Sequence. In the dialog that appears, you can see the four sections, each of which corresponds to one of the components in the repetition sequence. I have 4 faces and 4 videos, so this sequence of components needs to repeat 4 times, so I'll add another 3 rows. I'll quickly edit the labels so that they make sense. I've edited out all of the typing to keep the video tutorial short. We can now choose which properties of each of the components we would like to change across repetitions. The fixation crosses are the same on all trials, so we can ignore those. Starting with the image component that displays the face, we can click on the Properties tab and select the source file property, as this is something that will change across repetitions. The source file property now appears as a new column for this component, and we can go ahead and change the entries. We can also do the same thing for our 3 user variables. First, we'll add them all as properties, and then we can edit their values accordingly. We can then do the same thing for the video component. First, add the properties that will change across the 4 repetitions, and then edit their values accordingly. When we're done, we can click OK to close the dialog. And now the project is ready to be run. We can save it, then go ahead and collect some data. I ran a few participants and have imported the EDF files into DataViewer and saved the viewing session. For more information about how to use DataViewer, please see the relevant video tutorial series. As you can see, trials switch between fixation crosses and the stimuli. We aren't really interested in the fixation crosses, so the first thing we can do is regroup our data so that we can ignore or remove these trials. To regroup the data, I can click the Edit menu and select Trial Grouping. In the dialog window that appears, I can choose which variable or variables to group the data by. If we regroup by condition, you can see that our image and video trials each have their own grouping node, and all the fixation trials are grouped under null, because we did not set any values for this user variable in WebLink. We can either check the Exclude from Reports property or remove the trials completely. I'll remove them. Now, as with any other iLink data, I can do things like playback trials in the playback animation view. I can also regroup the data in different ways. I'll regroup by condition and emotion. We can also create heat maps or difference maps. I'll create a difference map comparing gaze to happy versus neutral videos. It looks like people are gazing more to the mouth and less to the eyes for videos of happy faces. We could also create interest periods and static or dynamic interest areas, and of course generate the usual range of output reports for further processing. I'll run a quick trial report to see if basic metrics such as average fixation duration and saccade amplitude differ as a function of the experimental manipulations. Notice that the user and participant variables that we created in the WebLink project are also available at the end of the variable list. I hope you found this video tutorial useful. Please do check out the other videos in this series, and as ever, if you have any questions, don't hesitate to contact our support service via the support forum or email.